In this video, we're going to talk about we're going to talk about annuity cash flow streams. An annuity, if you remember, is just a series of cash flows for a certain period of time that are all equal. We need to designate, though, when these cash flows occur. Financial calculators and Excel assume that the cash flows occur at the end of a period. This is what's referred to as an ordinary annuity. They happen at the end of the cash flow stream. An annuity due is when the cash flow occurs at the beginning of the stream. Now, annuity due problems are really going to be investment questions, right? Those all pretty much common sense says if you're thinking about investing, you're going to start today. You're not going to wait till the end of the year to start investing if you're thinking about it today. But we do have to understand that there's obviously differences. If you look at this particular table, what you'll see is these cash flows in the middle are all the same. So these cash flows will all grow the same way. But with an annuity due, the cash flow starts today. So this $5,000 is going to grow that many times till the end of this cash flow stream at the end of 5 years. But this $5,000 doesn't grow at all because it happens on the last day of the 5th year. So an annuity due will always grow greater or to a larger amount than an ordinary annuity. So here's our formula for the future value of an ordinary annuity. You can see that the formulas start to get fairly complex. Excel makes it pretty easy. It's the same future value calculation. Again, the rate is the rate per period, total number of periods. But here, since we are looking for the future value, this is going to be a payment. We're going to invest a certain amount of money every period. This is the payment per period. Since it's an investment, it's going to be a negative number. Present value is going to be a 0 because we don't have a beginning amount. And of course, the type, ordinary annuity, is always going to be a 0. So here's our example. You want to invest $2,000 a year at the end of each year for 10 years, compounded annually, and you can earn 12%. So in the spreadsheet, we plug this in. It's negative $2,000 is the payment. Ordinary annuity, so it's either going to be a yes or a 0. Up here, we have the interest rate and the time in years. Compounding is once per year because it tells us once per year. So the future value of this, $35,097. So that's the amount that should be in this account if you invest $2,000 a year, starting at the end of this year, and you do that for 10 years. At the end of 10 years, you should have $35,097. As I've done in the past, the next slide is an example. I would suggest you attempt to do that example and see if you could come up with the answer. Again, the answers are in the notes. For an annuity due, we have to adjust the formula. If you're doing the formula, that's this segment here. So you take whatever the future value of an ordinary annuity was, and you multiply it by, again, 1 plus r to the m, right? Or r divided by m. Or in the Excel formula, all you need to do is change the type from a 0 to a 1. And again, the next slide will ask you to do the previous example. But now let's look at an ordinary or an annuity due. Here's the formula for a present value of an ordinary annuity. Again, the math gets, the formulas get a little congested, a a little more complex, but remember the present value formula works. Now we'll be inputting payment. This means you expect to receive a payment in the future. So in this case, the payment will be positive. The future value will be negative in most problems. Now the type, again, ordinary annuity, the type should be a 0. I suggest always putting the 0 in there so you never forget. But quite frankly, in Excel, if you leave it blank, it will assume it's 0. So here's our example. We're gonna considering an investment. We're gonna receive $35,000 a year for the next 10 years. The investment for this, it's a low risk investment return, 4.79%. How do you find the cash in today's value? Again, payment, $35,000. Y or 0 for the ordinary annuity, 4.79, 10,000. We ended up the present value of this annuity, $273,038. So again, the next slide is an example utilizing the same kind of formula, same kind of concept, if you will. What do we do about present value of an annuity do? You have the exact same problem. We just have to add some complexity to it. But again, in Excel, all you do is change the type in the formula from a 0 to a 1. And this will provide the present value of an annuity due. And of course, we should see some definite distinctions between these values. Now, the longer the time frame, the higher the interest rate, the greater the difference will be from the annuity due to a ordinary annuity. The number of payments you make. We're talking about making annual payments, so it won't make that much difference. There will be some substantial differences, but in general, not that great of differences. But when you talk about making monthly payments, those distinctions, since the money's going to grow quicker, the difference between annuity due and ordinary due can be substantial. So here are two formulas that hopefully you see are fairly complicated. There are some problems where we're talking about annuity. It's a fixed payment, but we're going to kind of distort that a little bit and say, look, you have a fixed payment that has a fixed growth to it. So we might do this. An example of this might be a 401k, for instance, where you say, hey, I'm going to invest $300 a month, but every year I expect to get a 3% raise. So that cash flow is going to grow by 3% every year. So that obviously will increase the end amount, or the differing values will be different because we have this growth factor that we've incorporated. Now, it's a pretty complex formula. Present value of annuity with growth, future value of annuity with growth. I'm just going to show you the next slide where you can see that there are boxes down here where you can put this growth of an annuity here. And again, that will provide you with the end solution, if you will, of, in this case, present value of an annuity with growth. And then there's an example you can work on, future value of an annuity with growth. So that's the end of our discussion here of annuities and growth of annuities.